All right, welcome everybody. We're here today to talk our August edition of our Temporal virtual meetup, and the topic today is Saga without the drama. And I want to thank Natalie for coming up with that awesome title. And so today we're going to have a couple things going on. We're going to have, first, the presenters who will be talking to you today. So we have Jeroen, who is from Essent, and is going to be talking about the modernization of their IT stack, a radical modernization, may I add. And then we have Simon, who you may remember from all of these. Simon's a solution staff architect of Temporal, based out of the UK. So the agenda today is going to be the intro. You're here, welcome. As you enter the chat, feel free to add, where you're from, what you're using Temporal for, if applicable, or what you're exploring using Temporal for. Then we'll get into Simon's talk, Saga without the drama. We'll go right from there into Joren's talk about how they've done radical IT modernization at Essent. And then we're gonna pause for Q&A, and feel free as the talks are going to put your Q&A in the chat. We'll try to get to some of them as the talks are going. We might hold some till the end. And then finally, we're gonna leave a few minutes at the very end for Simon to pipe in with a little bit of a product roadmap preview for everybody. So we want to make sure that you know what we're about and you know what's coming down the pipes. So with that, I'm going to go ahead and just turn it over to, oops, not that yet. I'm going to turn it over to Simon. So Simon, why don't you go ahead and share screen and show us what you came here to talk to us about.
Hello, hello, hello. So my talk today is it's based on what was said in the last feedback form. So I'm going to do the plug straight away. We have a feedback form which we're going to send later. If you want to know something specific about Temporal, please vote for it in there. This is fundamentally the Saga pattern today, which is how we handle failures in distributed systems. It's 2025. We're all using distributed systems today. That's just the way that the modern tech landscape has gone, with all the different things we've got in the cloud and all of the different feature sets that we've got to deal with as engineers. Everything is fundamentally a distributed system in one way or another. The other way of talking about the Saga pattern is answering the question, what happens if step 3 fails after step 2 has taken your money? This is fundamentally what we're doing. The point is with the Saga pattern is that this is a system that does something without any knowledge of where it sits in a chain of events. So this is the do it all or don't bother. That's another way of also thinking of the Saga pattern. Now, I'm currently in the middle of planning a trip to Melbourne in March for the Australian Grand Prix next year, because I figured that either Oscar Piastri is going to win the championship or he'll need a big hug. And I thought, well, where better to do it than in Australia as next year? I need to find a way of obviously getting there. So I need to book a flight. I need somewhere to rest at the end of the day and sleep. So I need to book a hotel. And obviously I need to get my race tickets as well. Now, all three of those activities are linked. There's no point in booking a flight if I don't have a hotel. There's no point in getting a hotel if I don't have a race ticket. And obviously, if I don't have a race ticket, the other two things are entirely pointless as well. So I need to do that. So if you were going to do this as a piece of code, you would have this as this is your happy path. Simon wants to go to Melbourne. He books a flight. He books a hotel. He gets his race ticket. We get happy Simon. That's all good. But of course, because we've also got a code for the non-happy path, we also have to do this bit as well. So obviously, if I can't book my flight, there's nothing to do. We just go straight to the end. That's the end of it. Nothing left to do. If we book the flight and we go and book the hotel and the hotel booking fails for whatever reason, we need to cancel the flight and then we go to the end and we get sad Simon. If we book the hotel, book the hotel and book the flight, and then we go and get the race ticket and that fails, well, we obviously need to cancel the hotel, cancel the flight, and again we get sad Simon. So we end up with a failed state in that. These bottom sections, which is the undos, these are also known as the compensations. Now, these are not necessarily an undo function. In this example, they are an undo, but it's actually more of a way of resetting things to an acceptable state. So, depending on what we're doing later on, depending on what you're doing in your actual thing, you might not have to undo a booking. You might have just gone, well, let's go and reserve this flight, but then we'll go and do it at a later date. A good example of this would be, let's say you're doing a delivery system and somebody says cancel the delivery, but if the parcel's already left the factory and it's gone off in the van to go and be delivered, well then the compensation becomes, don't cancel the order as such, but we have to then send an additional step through to say, let's just tell the driver not to deliver the parcel. So that's the difference between when you've got the compensation, it's not necessarily an undo. It's just putting the state back into an acceptable state so that you can continue in what you're doing. There's two ways of doing a saga pattern, and that is choreography and you've got orchestration. Now, choreography is where the order is decided by the code. In this example, the book flight, it receives the book flight from maybe a web application. It goes and books the flight. The book flight then triggers the book hotel. The book hotel triggers the get race ticket. And obviously, let's say the book hotel, if that fails, well, it's the book hotel's responsibility to say, we've got to undo the book flight. So in each of these, that any particular event only knows what's triggering it and what it's doing afterwards. It doesn't know anything else in the grand scheme of things. The other way of doing it is with orchestration. Now, in this case, you've got a message broker, and it's the message broker that decides what we're actually doing and the order of things. So in this case, the message broker says, go off and book the flight. Once the book flight service has returned it's completed, it then says, right, okay, the message broker says go and book the hotel, and then it goes and books the race tickets. So it's the message broker in the middle that's doing all of the work, and that's what's maintaining that. The orchestration adds an extra layer, but it can actually be much simpler, which I'll explain in a minute. The choreography, there's good parts to the choreography. There's no single point of failure, and it's loosely coupled. However, the business logic is spread across your entire code base. Imagine, let's say you've got 10 services and you've got 10 different things that are going, and each one of those is calling a different service. You could be crossing across multiple concerns. It's doing things that it's not necessarily designed to do, and it's working in other services that you don't necessarily own. And also the complexity grows, because again, if you've got 10 or 20 steps in your workflow, somebody says to you, what actually is the workflow? You've then got to go and look at your documentation, and it can be quite difficult, especially if that documentation is not maintained and you don't necessarily have access to the code base. The orchestration, you get the full visibility of the flow, and it's easier to evolve, but it does have a single point of failure, and it's arguably harder to implement at the start because you've got to have the message broker. Now, those of you who are paying attention, or those of you who know Temporal, will know that Temporal is an orchestrator in this example. Temporal is your message broker, and it does all of the things that we expected it to do. Now, arguably, that because Temporal, with its emphasis on reliability and extensibility, I would argue that that means that the single point of failure drawback is no longer an issue. You could even argue as well that the harder to implement issue has gone as well, but maybe because for some people, I'm in the exalted position that I've used Temporal for a long time now, and I know Temporal quite well. But for people, we do have a learning curve with Temporal as well. So it is a learning curve, but it's maybe not a massive one. This is a code example. This is based on a bit of TypeScript, and this is my book trip function. So we have to declare a compensations object. Now, obviously, I've not written what the compensations object is, but that is putting the functions in order, maintaining the state of the functions, and then this exec function at the bottom is going to undo them and invoking them when they need to undo. But in TypeScript, it's a really simple application because we've got the book flight. If that fails, great. Well, there's nothing to do. We just go through and obviously preserve the error. If we book the hotel, well, the compensation added for the cancelled flight is there, and it returns that, it runs that cancel flight function. If we've booked the flight and the hotel, but we fail to book the race, well, there's no compensation after booking the race because we're never going to undo it at this point. If we wanted to add something else afterwards, we would then have to add a compensation for undoing the race booking. But in this example here, it's a relatively simple. It's we've only got 3 functions and 2 calls in between to record the state, and then we just run that state at the end of it. Okie dokie. A couple of pitfalls that we've got to be aware of as well. The Saga pattern is it's not a new thing. It's been around for 40 odd years, but there's still, like with everything, there's still things that we have to be aware of. The first one is it's a compensation, it's not an undo. As I said earlier, if you had the example where you've got a shipment of something and you've already sent it out, but you still allow your customers to cancel it. Well, in this case, we can't cancel the delivery because that's already gone. We're not necessarily going to get our money back if there's obviously a delivery charge in that, but we can then send a message through to the driver and say, yeah, this parcel is your next one. You don't need to deliver it. Just ignore it and bring it back to the depot. You've also got to ask your question: what happens if a compensation runs more than once? Temporal is a execute at least once service, not an execute once service. So sometimes if you get replays, etc., and retries, you could get in a situation where your compensation runs more than once. So you've got to obviously think about how you're going to do that. You might want it to make a database query to say, has this already been cancelled? You certainly don't want to get in the situation where a compensation fails because it's got the error message, this compensation has already run. So you need to think about that. Every transaction also needs a compensation. So you need to, any non-idempotent applications. It's just that it's made a change to the database. Effectively, if you think that it's an HTTP, anything that is a put, post, or delete function. So anything like that where you're making a change to your state, that needs to have a compensation. Obviously, it's just a read-only query like a get. You don't need to concern yourself about that because that's not going to have any problems with that. And finally, you've also got to accept that compensations can fail too, and you need to have a strategy as to how you're going to do that. You could say, well, I'm just going to leave it in a failed state, and that's then a manual change. You could then have a compensation failure strategy, etc. Again, that's more questions of what you need to do as a developer. I'm going to run through the demo now. This is the Saga demo inside our GitHub. So the link is on the screen. It's github.com temporal.io samples TypeScript. Now, in this example here, we have a nice application. This is the open account. So we're opening an account in your application. So maybe creating a new user in there. The first thing it does is it creates an account. So that's obviously going to create the account. And as part of this, we've decided that if this fails, there's going to be no compensation. We're going to maintain that you've still got an account. We're then going to add an address, and we then add in our compensations for the adding address, which is clear the postal address. We're then going to add a client. That's going to then remove the client if that does it. And we're going to then add the bank account. And if that fails, we'll sort that out. Then I'm going to press the wrong button. I'm going to flick all the way down. And then right at the end, we call this compensate at the end. So let's just run this and see where we go. So I'm going to load up my temporal application. Oh, that's not worked. The demo gods, I haven't pleased the demo gods. Oops, a daisy, I know what I've done wrong.
Live demos, everybody. Always a good time.
Yeah. Didn't remember what I was doing. Yes. Right. So this is one that's worked. And anybody who's looked at Temporal will know this screen very well. We've got the create account, we've got the add address, add client, add bank account. Nice and easy. Now let's look at that if it fails. So we're going to make the add bank account fail. And I'm going to follow this one as it goes through because this is a bit more interesting to look at. So as you can see, we've got the create account, add address, add client there. Add bank account has now failed, so it's now run these additional functions here. It's failed to add bank account, so there's nothing, we can't then do anything after adding the bank account. There's no compensation to be done with that. So we've removed the client, we've cleared the postal address, and because we've decided from a business logic point of view, we still want the create account to exist, we haven't undone that create account. And then we've returned the error, we've preserved that error so that the developer can say, well, this hasn't worked as we expected, but it's gone into the state that as a developer, we are happy with and we can deal with. Finally, some best practices to think about. Allocate before confirming. Then we're going to also allocate before confirming. If you can, use if you do a soft confirm, say yes, we're going to allocate this booking, and then there's going to be a confirm everything step at the end. So we don't actually then have to undo things by making transactions. If you have to do it that way, where you do that, then you obviously have to do it slightly differently. Keep your compensation small. So this is your single responsibility principle. It's the same with any temporal activity. Only have it make one change per activity. And your compensation, that is just another temporal activity. Make compensation safe to call multiple times. We need to make these idempotent safe. So if it calls it the first time and it undoes it, great. If it calls it a second time because the orchestrator has said we need to, it needs to know that it's called it a second time. It needs to still return the same data, but it needs to not fail to say, for instance, this has already been cancelled. Use retries within Temporal. They're there for a very good reason. Sometimes you might get a network outage and you just want to retry it, and the next time it then does it successfully, and that's fine. And that is what Temporal is there for. And also use Temporal's tracing and observability features. If you go and look at anything on the Saga pattern online, it always says, oh, it's much harder to trace everything across the whole stack. Or with Temporal, because that is exactly what Temporal is there. It's used to maintain distributed systems. You've got that flexibility, and then you can add in additional things to make your application much more robust. And then a minute, exactly 15 minutes according to my clock. That is my talk. Thank you very much.
Amazing. Thank you so much, Simon. Great job. We do have a question in the chat. Manjeet, we'll get to it during the Q&A part, but for now I want to go ahead and transfer over to Jeroen, if you want to jump on, share your screen, and then we'll hear what you have to say.
Thank you, and thank you, Simon, for the amazing talk. Yeah, so I would like to tell a bit about Essent's radical IT modernization journey, or as I like to call it, turning a soap opera into an epic saga. Before I dive into that, a little bit about me. I'm Jeroen Vollenbroek. If you want to know how to pronounce that, I find the pronunciation spelling to help. I've been in the software engineering industry for over 16 years now. It's a bit fuzzy because I started as a hobby, so when do you start counting? And I'm currently an enterprise architect and pathfinder at Essent. And that means I'm involved with basically future-proofing or technology landscape, leading all kinds of migration decommissioning efforts and making sure we get a certain agility and flexibility for or changing business needs. At the same time, I'm also a consultant. I'm principal consultant backend engineering at Navarra. Navarra is a small consulting firm in the Netherlands. We're based in Driebergen, where I'm mainly advising clients on IT strategy and architecture, especially when it's about modernization projects. I help and coach a lot of teams there. And last year, I started the BPM to Temporal Converter initiative, which I will talk a bit more later. So about Essent. Essent is the leading energy supplier in the Netherlands. We have about 3 million customers. There were a lot of mergers in our history, but we date basically all the way back to 1940. And we currently have the ambition to become a one-stop energy shop, meaning any kind of energy related questions and products you might need, well, we should have them. And our current product portfolio includes the basics like electricity and gas contracts, but also things like city heating networks, solar panels, home batteries, heat pumps, heating, home isolation, and e-mobility, so electrical vehicles, charge points, and cards. And we have a rather big IT department. There's about 300 engineers in there. I would like to take you along on a little trip down memory lane, back to the energy crisis of 2022. So what we noticed as an energy company is, well, there were a lot of geopolitical events in 2021 and 2022, and it basically caused the supply of natural gas in Europe to diminish. And this scarcity started driving up the gas prices by quite a lot. They reached 10 times their baseline in October 2022. And of course, as a consumer, you will notice that. So this sudden increase in cost, yeah, it really made customers think about their energy consumption and their energy contracts way more than usual. So as a result of that, we basically saw our inbound traffic increase by the same amount. So suddenly, basically overnight, we experienced a 10 times increase in traffic, which, as fellow software engineers, you probably can imagine, gave us quite a challenge, because, well, as an older company, we had a lot of legacy IT systems. So we were faced with the question: can we actually scale these systems sufficiently well to cater to this new reality? So this turned into a sudden reality check. And in order to answer the question, can we handle a 10 times traffic increase? I should probably add using our self-hosted physical servers in some data center. Well, the answer is absolutely not. We had quite an outage. It took almost a week. And yeah, things were not that nice at the office, so to say. So yeah, that does lead to the question: what do we do now? How do we deal with this situation? And it turns out the outage was one that we couldn't easily fix, because we had an overloaded central event bus. So all of our integration services, all of our APIs, all of our workflows, they all were connected to the same service bus, and well, that was running onto bare metal machines. So we started a lot of scaling efforts, but due to it not being able to scale horizontally, the only thing we could do was vertical scaling. So it rather quickly became apparent that was not going to be an option for us. So in parallel, we started a migration task force where we said, well, let's see if we can migrate the most heaviest consumers of our landscape towards a new technology stack. And of course, we already had development teams working on our new technology stack, which is AWS Lambdas with AWS API gateways. Yeah, that stack is something we started looking into. Yeah, and as you can see at the bottom of the screen, so this outage basically extended to all core components. So our API gateway had a problem. The JMS buses that connected everything together had problems. We had API services behind. We had some backends that couldn't handle it, and we had business process management workflows that were handling everything from customer onboarding to complaints to processing inbound documents. Yeah, basically all of that. So ideally, we wanted a solution that covered all of these products and migrated it to a target state. So yeah, the conclusion was we needed a radical change, and we needed it really, really fast. And those two tend to not go so well together. So we made a transition strategy where we said, well, let's focus on rebuilding the most important APIs, things like get a customer, or things like get supply addresses where energy is being delivered, and rebuild those to Lambdas, because they can scale a lot better than these bare metal machines. And this relieved the load on our landscape enough to at least restore availability, albeit with like a queuing mechanism in front. So people sometimes had to wait a little bit to get on the website. And after that was finished, we started setting up a bit more of a safety net for further conversions. So we made a lot of tooling and insights to see how well we're doing. And we started converting all of the public GET APIs. Why just the GETs? Well, those were easiest to convert because you can compare them. The old API with the new API, these were all one-on-one conversions. And this reduced the heaviest load on our landscape. It was like 80% of traffic. Followed by, of course, all of the other APIs. So all of the things that mutate, all of the internal APIs. There was a lot of soap calls in there. And we made 4 teams to do so. Followed by what we like to call our last refactoring year, where we did a lot of dividing of APIs into logical apps. There were of course some refactorings going on, and we also took this opportunity to do domain-driven design sessions with our business and IT. There was a lot of training and event storming involved, and this helped us refine our landscape. Which gets us to the current stage, which is, well, we still haven't fully migrated all of these BPM workflows. Yeah, now that the landscape is all stable and we still needed a solution for the workflows, that got us to think, how can we approach this? So we had one team doing a manual transition from a existing BPM workflow to Temporal. And we got quite a lot of learnings there. I think a lot of these boil down to things being very costly. Because once you start migrating over 500 workflows, you rather quickly find out that it's not easy to do that step by step. You either migrate a full workflow, or you're going to make changes to both the legacy workflow and the new workflow, because every time you migrate a small part, well, it also requires a change on the legacy version to make it aligned and have it branch out to your new workflow at that exact moment. The same also holds for validation of those workflows. So the legacy workflows often didn't have automated testing. And there were like manual testing scripts which you can execute, but they take quite a while. And if there's like a new version introduced, then well, the entire workflow is duplicated and the version is applied there so that you can finish the legacy executions. Well, if you have worked with Temporal before and you did workflow versioning, you know the kind of problems I'm talking about. And if you actually get business change, so if there are people that want the workflow to change while you're in the middle of a migration, you need to apply this change twice. One time for the legacy workflow and one time for the new workflow. So after we evaluated these first migrations, we concluded that it actually always leads to a one-on-one conversion before you start doing any refactoring. And I think that's a really important lesson that we learned there. It makes no sense to redesign things and rebuild things while you are migrating, because that actually makes the cost of validation and migrating it even worse. So we said, is there a way we can speedrun this one-on-one conversion, then validate it by just recording event histories on the legacy workflows and replaying them against our temporal workflows? And once we have validated that functionally all workflows are behaving in the same way, we can start a proper refactoring in Temporal with all of the tools that Temporal offers. So what we were looking for, in short, was a transpiler, a machine where we can input all of our existing workflows, activities, scripts that are in there, data models. There are some human-in-the-loop situations where forms are being presented to employees, together with the audit trails. And then have some project templates that we can apply on those generated workflows and end up with TypeScript processes in Temporal that contain the workflows, the activities, also the scripts, but then it's TypeScript code, all of the classes and interfaces that are being used, and the human-in-the-loop forms as Angular components, so we could put them in our employee software. And that's basically the journey we set out on. So we defined a few different steps, discovering how all of the workflows relate, because of course you have workflows that can have child workflows that can then start more child workflows. So we needed to cluster all of these workflows together since they were in one big product. Then we made some analysis tooling using all of the learnings that we had in the API conversion. So there are a lot of different activity types in these workflows, like call an API or start a subflow, maybe wait for a signal or run some JavaScript. Yeah, and at that point, we started creating a sample Temporal app that contained a project structure in the way we wanted our future to look like. And we turned that into templates that we could load into the compiler. So we wrote scripts that first translate all of the workflows, the BPMN workflows, into workflow functions. And for each of the different activity types, we also made templates that could be injected with some information in order to perform the same functions. Then we set up a conversion pipeline, which is basically a Git job that runs in a GitLab job that runs on a nightly basis. It pulls in all of the BPM source of our legacy systems. It tries to convert it, and it also keeps track of some metrics like are there errors in the conversion, and it outputs all of the converted projects into a standalone repository. And this enables our teams to check out that code, make sure that they feel confident putting it in production, or maybe establish some training needs or development roadmap that needs to be followed up on. And as soon as they are confident, we can have each team pull out their Temporal app from the generated repo, and gradually take it live by performing canary releases in a controlled way. There's some tooling for that as well. And review the validation results and make sure that these workflows go live one on one. So yeah, that has been quite a journey, and we learned a lot of stuff there as well. First and foremost, compiler design is quite a complicated topic, and that's not a skill set that every engineer has. So we took quite some time getting really skilled engineers together that have been working and researching compilers and all of the patterns and structures underneath it. And I think that is one of the key successes we had there. You also need to make sure that you can actually perform automated validation of your workflows. So all of the event histories need to be accessible and retained. One of the issues we ran into is as soon as a legacy workflow ended, immediately the event history was deleted. So that makes it quite complicated to perform a proper validation with. But as long as you have a good quality replay data set, and that might require some configuration or capturing of data, you can perfectly well do that. And you need to have really good insights into all of the ways that your workflows communicate, because there's more than just starting a workflow. It's also all of the side effects, things they might do in a database or API calls that they might make. So as long as you have the proper picture of what it does and doesn't do, it also helps a lot in speedrunning this first part of the migration. And finally, of course, having a one-on-one conversion is not the end goal. You really need to include refactoring time and make sure that people actually get refactoring time and not consider the journey to be completed once you have a converted workflow. So with all that, let me take you to an example. So what you see here on the right-hand side is a BPM workflow for sending an email, including coded retries and error handling forms for agents, and the kind of TypeScript code that we can generate nowadays by just pulling this workflow through the transpiler. And you can actually see a lot of similarities. So each of these activities got a corresponding execute activity function call on the left, and all of the branches and decisions and conditions were turned into if statements. And there's a bit of recursion here because, of course, we have errors feeding back into the loop. So it's difficult to make those kind of structures in one single function. But we decided to make a sub workflow function whenever a scenario like that occurs. So whenever you have a arrow coming from a future state back into your activity, that's when we branch off into a dedicated workflow function. And this is something that engineers can really easily convert into something that is a bit more maintainable. For instance, you could turn the previous workflow function into something like this by adding a do-while structure and removing the technical handling of errors, because in Temporal we have better tools to do that than just manually coded way. And yeah, that's the journey that we're currently on. We have lots of teams going and are lined up for this migration. We have some teams that also started manual migrations or redesigns already. And yeah, very excited to be on that journey and to see where all of this is leading. So of course, we also have some metrics. After we went live with the first workflows, we noticed 8 times improvement in deployment frequency. So we went live way more often. We also saw an increase in our lead time for changes. We saw our change failure rate go up, so the amount of deployments that lead to either a rollback or incidents. And we got a way lower mean time to recover. So if something went wrong, it became mainly due to the temporal user interface a lot easier to see what actually went wrong and how to recover from that, especially combined with the smaller deployments. So yeah, this is not just a little party within the IT department. This is actually something that extends to our entire business line as a really positive change. And with that, I would like to thank you for listening and hope that there are questions.
Wow. I've never seen this problem that you're talking about handled in that way. That is so cool. All right. Thank you so much. That was amazing. So what we're going to do at this point is, yes, transition over to Q&A. As we transition over to Q&A, I just want to throw up a slide, which is this one. Because we have a survey, and we'd love to know what you thought about what you've heard today, as well as what topics you want to hear about in the future. So I'm going to leave this up for a little bit, but in the meantime, we had a couple questions I see in the chat for Simon. So maybe we'll do those first, but if you have other questions, go ahead and use like the Zoom raise hand feature or pipe them to chat, whatever you're more comfortable with. Manjeet, did you want to come off mic and ask your question, or else I can ask it on your behalf? Okay. The question was, what if the cancellation, so this is going back to the Saga pattern talk, what if the cancellation is not allowed, for example, flight once books are non-refundable? Or are we assuming that compensatory, I think that's how you pronounce that word, transactions are always possible?
Yeah, I mean, this sort of goes back to, I mean, Donald's answered it well already. So there's a written answer, which is from Donald. But this is why I was making the point that it's compensation is not undo. You're compensating it and making sure it goes back into a state that is acceptable for you. Now, if in this case you can't cancel the flight, well, that's fine. You can't cancel the flight, but you have to then put it into a state to say, we're not taking the flight, we need to make a phone call, for instance. Maybe you can't do it automatically, but then you can do it with a phone call to the flight, etc. But that's fundamentally the difference between an undo, which would be cancelling the flight, and compensation, which is, you know, an alert to say you have to phone up about this flight, for instance. As Donald says, yes, there's always going to be a grace period with the flight, but again, there's going to be times when you can't undo it, but it is a compensation in that respect.
Right.
Hopefully that explains it a little bit further.
Awesome. And then Raymond, did you want to come off mic and ask your question?
Sure, thank you. Yeah, hi Simon, thanks for the talk. I was just curious, I've seen a few different sources that say it's important to register the compensation before you register the original action to do, instead of the other way around. I was wondering if you, in your opinion, does that matter or not matter, and could you explain why?
I haven't seen those, so if you have got anything like that that you can share and just stick it in the chat, I'd be really interested to read that. I've not seen that, so I don't really know. But my feeling with that is that you're not going to be undoing it before you've done it. So It's registering that as well. It could well be that let's say you need to put a parameter in to say that let's just say the cancel flight. Maybe it needs the booking ID as well. You're not going to know that until you've triggered that task to do the compensation. But my feeling would always be that you would do you'd register the compensation after that you've actually done the task. Like in my TypeScript example, maybe there's caveats to that in specific languages. I don't know. But yeah, I'd be really interested to read some of those and understand if there is a reason for that as well. What languages are these written in?
I think they were in Go. I'll try to find them. Thank you.
Yeah, I did wonder about Go because the error handling. I was talking to Donald about this morning. I'm a proponent of Go, but I always find the error handling in Golang irritating because sometimes you just want to throw an error and not have to deal with it at all, which you can't really do in Go.
Right on.
Yeah, thank you.
Thanks,
Yeah.
Ray. Thank you for the question. Do we have any questions for your ends talk? And if not, I've got one. So maybe while people are formatting, I just want to know, like, so you're at the whiteboard or whatever, and you're mapping out these steps of this migration, and you're like, holy buckets, this is going to take a million trillion years. We need to figure out how to do this faster. And somebody raises this idea of like this transpiler thing. And like, so I just want to know, like, what was it like to be in the room when that conversation was going? Because it's a very interesting way of dealing with the problem, right? And like you said, you need specialized skills to do that. But just like, I'm just curious, like, what was that conversation like? Like, what led to that solution being explored?
Yeah, that was I remember the moment quite well. So we did these first few manual migrations by hand, and they did not go as quickly as we had hoped. Not necessarily because of Temporal as a platform or anything, but mainly because we were struggling a lot getting business requirements clear. So we first aimed for a full redesign. And then in these meetings, it became apparent to us that it was actually the redesigning that took a lot of time. And then as you started to redesign, we ended up with the exact same flowcharts that we already had. And that is because a lot of our existing engineers, but also our business people, tend to give the answer, I don't know, just do whatever it does right now. Yeah, when we started to realize that that was actually a pattern that led to us redesigning the processes in the exact same way, we started to challenge it. So why are we doing that? Why are we not changing the way our workflows look? And that's because they are functionally correct. We're catering 3 million customers with those. It's just the technology that wasn't as nice. So yeah, we had a lot of going back and forth on that. And at one point we just said, well, if it has to be one-on-one, then let's go like 100% full in on one-on-one. Because if we do that, we get a lot of benefits. If we go like 99% similar, we can't do replay-based testing. We can't do automation. We can't do any of the things we're doing now. And that really led to the question: is the possibility of having like a 2 or 1% difference in functionality really worth sacrificing all of the possible speed gains that we could get with 100%? Yeah, and that's at that point we agreed that 100% is really worth the benefits you get in that sense.
Nice, yeah. And then the question is, now that you've done that for several of your workflows, like have you then made use of some of the new functionality of Temporal now, or are you still kind of just in the migration phase?
So we planned about 1 year for the full migration cycle, because we didn't want to force each and every team to do it at the exact same time. We have some teams that are currently fully building new workflows in Temporal as well. So for those, yeah, obviously we are using the full feature set. And for the converted ones, what we see mostly is teams keeping the activities around for longer than the workflow functions themselves. Because the first thing people start doing is cutting out stuff. Like if a current workflow has technical error handling, yeah, it really doesn't make too much sense to keep that in the workflow because Temporal does that by default. So it's just a matter of cutting away those retry mechanisms and error handling scenarios. But once you get there, of course, a lot of subflows are being invoked that are like fully written from the ground up.
Great answers. Thank you. Giora, did you want to come off mic and ask your question?
Yeah, sure. Like I was hearing the talk, and then you got to transpilers, and then I realized I didn't hear the part where how the workloads were defined that you could actually transpile them to different code. Did you actually take like source code and analyze it with AST and the stuff like that, or was it defined in like a graph kind of definition language or some sort? I'm not sure like what system used originally, and like what was the source that you transferred to TypeScript or Java, whatever you use with Temporal?
Yeah, so the original workflows were written using TIBCO BPM. And for those who don't know TIBCO BPM, it's using a XML format to describe flowcharts. But in those flowcharts, you can have embedded scripts. They call it JavaScript, but it really is a subset of JavaScript because you can't do things like define a function there in there. So it's a really limited subset of JavaScript that you can add. And that's also why we said let's pick TypeScript as a target, because we already had TypeScript teams and JavaScript to TypeScript conversions are not as difficult as like a Java to TypeScript conversion. But one of the things that we noticed there is that there was a lot of code duplication. So in our original situation, we had like over 2 million lines of JavaScript code, but there were blocks of code that had been duplicated over 1,600 times. So that's 1600. And in the converted code, you can just search replace those blocks and replace them with a utility function. So one of the really cool learnings that we had there was, hey, our low code solution where we have a lot of flowcharts and JavaScripts actually has more code than our coded solution. So it's not really low code if you think about it that way. But yeah, it's JavaScript.
Wow, that's hilarious. All right. Meanwhile,
Thank you.
Thank you so much. Meanwhile, if you're on the edge of your seat about that resource that recommends the opposite of what Simon was saying, we found it. So Raymond found it. Donald found it. Simon, do you want to revisit that question in
Yeah,
Yeah.
I've had a quick read of it, and I mean Donald sort of, I think, got the nub of the issue there. That in the event of a failure, the compensation is registered, but it's if the action is partially completed or it's failed in a way that would otherwise skip compensation registration. Now, it's funny. I read what I thought was all of the temporal Saga patterns blog posts. I missed that one. So yeah, I've learned something there. So well spotted. I would argue. I'm going to make the argument without any fear of recrimination or retribution that if you focus on doing a small single responsibility action, then you don't want to be doing, you don't need to do it beforehand. However, I'm going to absolutely accept that there are going to be times when you might need to do that as well. So I guess the fundamental thing, my answer to the question is register it correctly as based on your requirements at the time. You might want to do it beforehand, you might want to do it afterwards. It's sort of, that's your mileage may vary as far as I'm concerned. But yeah, the way I've written my stuff, it would be afterwards, but I can see that I accept there's going to be times when you might want to register it beforehand for the reasons that have been discussed.
Great. All right. So it depends. No, I'm just kidding. But yeah, that's a good answer. Your mileage may vary. Okay. So Simon, I'm going to turn it back over to you again to share your screen. You were going to do like a product roadmap update.
Yeah, I've nothing to share. This is almost just like the news headlines of some of the things that Temporal has introduced from the roadmap over the last couple of months. We have 3 ways of describing releases. We do pre-release, preview, and general availability. General availability, that's fairly obvious. That means that everybody can use it, and that's great. Preview, particularly in Temporal Cloud, that is something that is available if you want to do it, but it's not turned on. You can turn it on if you need to in the settings. And pre-release, again in Temporal Cloud, that is you go to your account manager or raise a support ticket request and get access to it that way as well. Also, pre-release, it might not be available in every single language as yet, whereas once we get to preview and general availability, there's more support for that across. There might be the occasional exception to that, of course. Okay, so the few I put 3 for each stage. So in pre-release, environment config. That means that we're doing a thing where you can configure your temporal client in your language of choice from either environment variables or static config. So you don't need to keep defining. You can then just call your temporal client. Private connectivity. We've already got some private connectivity at the moment, but it's limited. And you have to do it. You have to get a support ticket for that. The 2 parts that we're adding in is limiting cloud access to private connections and allowing self-management as well, which is a big feature request we've had recently in sales. And priority, where we allow the priority of activities to be executed by order of priority, which is very useful if you're doing thousands and thousands of calls at any particular moment and you want to make sure things go through in specific orders. In preview, it was only announced yesterday, and it's the thing that's just really obvious. I don't know why it hadn't been done before, which is namespace tags, where you can add tags to your namespace so that you can search for namespaces, etc. A lot easier, and that is going to be a really useful thing on there, particularly if you want to do things like production and staging namespaces. Worker versioning, the next stage of versioning your temporal apps. That's a huge minefield, so I'm not going to go into it too greatly, but if you were here last time and you saw Ugo talking about patch versioning, this is the next stage on top of that. And we've also in preview announced multi-cloud replication. So if you want to transfer your stuff between AWS and GCP automatically, then that can be done so that you can build up resiliency. In general availability, multi-cloud replication is now in there, so that gives you 4 nines of reliability, increase from 3 nines, which is what you normally get. Self-serve upgrade and downgrade of plans between enterprise and business. Again, that just means you don't have to message us to say, can you click a button for us? And updating with start. That means that you can run an update. You can run an update on a non-running workflow. Again, that's one of those really useful things that just makes life a lot easier for developers when some of the things you get asked to do. So those are 9 things that I've picked out in the roadmap. Hopefully those will be useful to you. And please message us on the support or in our channels if you want to talk about those more.
Amazing. Thank you so much, Simon. Yeah, it's funny because we, post a lot of blog posts and emails about this stuff, but it's always great to kind of get a rundown of it kind of all together. So we're pretty much at time to close us out. I want to talk about a couple of upcoming events. So if you liked this, you might like other things. So let's talk about that. Joran, this is your event. Do you want to talk a little bit more about this?
Yeah, thank you. So we work together with Essent, Navarra, and Temporal to organize a meetup in Den Bosch in the Netherlands. It's at the office of Essent. There's various talks about the past that actually resembles this talk a lot, but also the present and the future state where Essent is really aiming towards more agentic AI kind of solutions using the Temporal platform as well. And we've done a lot of experimenting on, when would you like a workflow to be deterministic, and when would you like it to be more agent-driven? And what does that do with like decades of engineering wisdom? How do we make sure the code is maintainable, that the processes are repeatable, etc. So if you're interested in that, I think the link is in the slide at the bottom right corner.
Whoops. Yeah, let me get that in the
and in the chat.
Yeah.
It's at the September 17th. There's some pizza and networking events included as well. If you want to learn more or talk to us face to face, feel free to enroll.
All right, manual typing for the win. I will get those queued up in the future. Thank you. The next event, this is Simon. Did you want to talk more about this one?
Yep. Just on the last one there, if you do turn up to that in Den Bosch, you'll meet both your own and me. We'll both be there, and I'm hoping that your own will bring one of the delicious bossa balls, which are a delicious local delicacy. And he brought last time we had some there as well. I'm doing a hackathon in Stockholm the day after September the 18th. We're building a load of stuff with AI in TypeScript, and I'm going to be one of the judges judging it and talking about Temporal as well. So if you're in Stockholm, please come along.
That sounds excellent. All right. And then last but not least, certainly not least, we have another one of these coming up in a month, September 24th. So kind of we're going on a cadence of like the third Wednesday of the month. If you go out and find this event, you'll see that it says topic coming soon. And there's a good reason for that, because we want to know what you want us to talk about at that meetup. So once again, I'm going to plug that survey. I'll put a link into the chat to that again. We really value your feedback on these so we can continue making them better and talk about topics that are relevant to you and that you want to learn about. So at any rate, I wanted to thank everybody for coming. Thank you to our wonderful speakers. Thank you to Simon and Yoren. It was really great to hear your perspectives on different temporal problems. And thank you so much to everyone who joined us today. And we'll see you at the next one. Thank you so much.
Bye all.
Bye, everyone.